Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to the today's presentation on random variables and probability distributions part 5. In the today we are going to solve some problems on discrete random variables and discrete probability distribution. A random variable is said to be discrete if it takes finite number of values, and a probability distribution of a discrete random variable is called discrete probability distribution. Now coming to the present problem, from a lot of 10 items containing 3 defective items, a sample of 4 items is drawn at random. Let the random variable x denote the number of defective items in the sample. Find the probability distribution of capital X. So here, what is the given data? First, we need to know what are the given values and which is required to find from a lot of 10 items containing 3 defective items. So total number of items n is 10. Out of 10, the number of defective items is equal to 3. So that means the number of good items is 10 minus 3, there will be 7 good items, non-defective items. Now from this sample, 4 items are drawn. So here different numbers are given. This 10 denotes the total number of items and 3 defective items. Out of 10 there are 3 defective items. So 7 non-defective items, and from that sample 4 items are drawn. Now X denote the number of defective items. So let capital X denotes the number of defective items. Then find the probability distribution of X. Probability distribution means the set of all values of X and corresponding probabilities. So for that, first we need to identify the values of X. Here, since X denotes the number of defective items and there are 3 defective items in the sample, X takes the values, X maximum number of defective items 3, or we may get 2 defective items or 1 defective item or 0 also. If 4 items are drawn, out of 4 we may get 3 defective items, all the 3 are defective, 1 is non-defective, or else 2 defective items and 1 non-defective item, 1 defective item and remaining 3 are non-defective, or 0 defective items, that means all 4 can be good items. So here X takes the values 0, 1, 2 and 3. That means X takes 4 values, so it comes under discrete probability distribution since X is a discrete random variable. Now we need to find the probability distribution of capital X. So to find that, first we need to find the probability of capital X equal to small x is how much, where X takes the value 0, 1, 2, 3. That means probability of 0 defective items, probability of 1 defective item, probability of 2 defective items and probability of 3 defective items. We need to calculate all these values. To find this, we take the help of permutations and combinations. So here probability of 0 defective items, and again here we need to note first there are total 10 items. Out of 10, defective items are 3, so non-defective items are 7, and from this sample of 10 we are drawing 4 items. So we are selecting 4 items. There are total 10 items, so we can select in 10C4 ways, and out of those 4, this is the total number of cases or total number of possibilities, and out of these 4, how many defective items should be there? Here capital X denotes the number of defective items. Here capital X denotes the number of defective items, and X equal to 0 means all 4 must be non-defective. And how many non-defective items are there? There are 7 non-defective. So these 4 must come from those 7 itself, 7C4 by 10C4. This gives the probability of 0 defective items. If 4 items are selected from 10 items, the probability of 0 defective items is given by 7C4 by 10C4. If you calculate this, we will get 1 by 6. And to find that NCR, as all of you know, the formula is n factorial by r factorial into n minus r factorial. So, using this you can calculate 7C4 and 10C4, and simplifying you will get 1 by 6. Similarly, we need to calculate probability of one defective item. Now, here again the denominator is the same, because we are selecting 4 items from 10. We are selecting 4 items from the 10 items. So, the denominator is the same always, 10C4. We can select 4 items from 10 items in 10C4 ways. If there are n items, we can select r items in NCR ways. So, 10C4. And now coming to the numerator, there must be one defective item. So, out of 4, there must be one defective. What does it mean? Remaining 3 must be non-defective. So, there are 7 non-defective, and the remaining 3 must come from those non-defective items, and that one defective item from 3 defective items. So, 3C1, 7C3 into 3C1 by 10C4. So, the result is 1 by 2 here. Similarly, getting 2 defective items. Once again, the denominator is the same, 10C4, and numerator there must be 2 non-defective items and 2 defective items. Non-defective items must be from 7 items, and defective items from 3 items, 3C2. 7C2 into 3C2 by 10C4, that gives the probability of 2 defective items, which results as 3 by 10. And here x takes 4 values, total 4 values, 0, 1, 2 and 3. So, the probability of 3 defective items out of 4 items selected at random, there must be 3 defective items, and total number of defective items is 3, and so these 3 should come from those 3 itself. And if there are 3 defective items, the remaining one must be non-defective, should come from 7 items, 7C1 into 3C3, which results as 1 by 30. So, we have obtained the probabilities of 0 defective items, 1 defective item, 2 defective items and 3 defective items. Hence, the probability distribution of number of defective items is given by, let us construct a table with x values and corresponding probabilities. X takes the values 0, 1, 2, maximum 3, and for x equal to 0, 1 by 6 is the probability, 1 by 2, 0.5, 3 by 10, 1 by 30. So, this is the probability distribution of defective items. Now, coming to the next problem. Here, this problem is related to games. A player tosses 3 fair coins. A player tosses 3 fair coins. He wins rupees 500 if 3 heads appear, and rupees 300 if 2 heads appear, and rupees 100 if 1 head appear. On the other hand, he loses rupees 1500 if 3 tails appear. Find the expected value of the game. The question is to find the expected value of the game, and is it favorable to the player? Justify your answer. So, here the actual experiment is tossing 3 coins, but this experiment is related to the game. A player tosses 3 coins. That means the total number of elements of the sample space will be 2 power 3. So, there will be 8 outcomes. And what are those 8 outcomes? The sample space contains all 3 heads or 2 heads, 1 tail, and for this there are total 3 possibilities, HTH, THH. In all these 3 cases, there are 2 heads and 1 tail. Similarly, 2 tails and 1 head, and 3 possibilities for this. So, HTT, and there is another case, all tails. So, these are the outcomes of this experiment of tossing 3 coins. Now, this experiment is connected to the game. How it is connected? The player wins rupees 500 if 3 heads appear, and he wins rupees 300 if 2 heads appear, rupees 100 if 1 head appear. So, the result here, the result is connected with the amount. So, I can assign, these are non-numerical values. And what is the definition of random variable? Assigning a real number to each and every outcome of the experiment, every non-numeric outcome of the experiment. So here, instead of writing this 3 heads, if 3 heads appear, he wins rupees 500. So I can assign the real number 500 to getting 3 heads. Next, 2 heads. So these 2 heads and 1 tail. For this I can assign 300, because the player wins 300 rupees if 2 heads occur and 1 head occur. So these 3 I can assign the number 100 to these 3 outcomes. And on the other hand, the player has to pay 1500 rupees if 3 tails appear. 3 tails, that means the last case, here the player has to pay. So all these are positive entries, but now the player has to pay, so minus 1500. So that means here actually if x denotes the number of heads, then there are possible values of x are 0, 1, 2 and 3, since 3 coins are tossed. So maximum 3 heads, minimum 0 heads. But the same, this getting all tails is connected with minus 1500 and getting 1 head 100, getting 2 heads 300, 500. Now what are the probabilities? So these probabilities we need to calculate, and we know the experiment, 3 coins are tossed and total number of elements 8. So what is the probability of getting 0, 1, 2 and 3? So here probability of getting x equal to 0, which is probability of, if 0 heads he has to pay 1500 rupees. So there is only one possibility when he has to pay, if all tails occur. So all tails in one and only one case it is possible. So 1 by total number of outcomes 8. Similarly, x equal to 1, that means he will get 100 rupees. 1 head means 100 rupees. 2 heads, he will get 300 rupees. 3 heads, all 3 heads, he will get 500 rupees. So all 3 heads also possible in one case out of 8, and 2 heads in 3 different cases, 3 possibilities are there. 2 heads, 3 possibilities, 1 head also 3 possibilities. Hence, the probability distribution in the present game is given by x values as amount minus 1500, 100, 300, 500, and corresponding probabilities just now we have calculated 1 by 8, 3 by 8, 3 by 8 and 1 by 8. In fact, in this experiment, if x denotes the number of heads, their values must be 0, 1, 2 and 3. These are the values. But these values, getting 0 heads and paying 1500, both are one and the same. Getting 3 heads, the result getting 3 heads or gaining 500 rupees, both are one and the same here. That's why we replace the values of x by the amount, since the experiment is connected with the game and the amount. So now the question is find the expected value. So that means expectation of x. What is expectation of x? Sigma xi into pi. So minus 1500 into 1 by 8 plus 100 into 3 by 8 plus 300 into 3 by 8 plus 500 into 1 by 8. If you calculate this total, so this is minus 1500 by 8 plus 300 by 8 plus 900 by 8 plus 500 by 8. So after simplifying this, 3 plus 9, 12, 12 plus 5, 17, 17. So minus 1500 plus 1700 by 8, which results as 200 by 8, which is 25. So therefore, the expected value of the game is 25. Now another question is given, is the game favorable to the player? So here, since the expected value is positive, it is favorable to the player. So, if we get a negative value, it is not favorable. Since the value is positive, yes, it is favorable. So, it depends on the amount. Here minus 1500 he has to pay, and he will get 100, 300, 500 if 3 heads, 2 heads and 1 head occur. If this amount is different, we may get a different value also. So, that depends on the amount given in the problem. And finally, since the expected value is 25, which is positive, the game is favorable to the player. So, in today's session, we solved 2 problems on discrete random variables and discrete probability distributions. And in the next session, I will consider the continuous probability distribution. That means probability distribution of a continuous random variable. So, we solve some problems on continuous random variable and continuous probability distribution. Thank you very much.